This is again about the differential equations. So a differential equation is an equation that involves x, y's, and derivatives of y. So let's find the general solution of each of the following. So here we have y prime is equal to 2x to the third. So this is definitely an equation that involves a derivative, y prime, and then the variable x. All right, so now what are you going to do about that? Well, I am going to rewrite y prime as dy dx is equal to 2x to the third. Then I will rewrite this in differential form. So that would be dy is 2x to the third dx. And then I am going to go ahead and take the integral on each side. So integral, integral. So the integral of dy is y. And then the integral of 2 x to the third, I can bring the 2 out in front, so 2 integral of x to the third dx, but then I can go ahead and rewrite this so that it's 2 times x to the 3 plus 1 over 3 plus 1 plus c, so that y is equal to 2x to the fourth over 4 plus c, and 2 over 4 is a half. So it's y equals a half x to the fourth plus c. And this is what is called the general solution. All right, this is called a general solution, meaning that I actually do not know what the solution is for some initial value of x. All right, so I don't know what this constant c is. So that's what I mean by a general solution, is it's a solution for all of these values of c. All right, so here is another example. dr d theta is equal to pi. So I want to rewrite this in differential form. So I'll multiply essentially by d theta. So dr is pi d theta. Then just like before, I'm going to take the integral on each side. So the integral of dr is r, and the pi can be brought in front because it's a constant. So pi integral of d theta, and the integral of d theta is theta, so pi theta plus c. So this is the general solution. So hopefully that all makes sense of what is going on here, of why we needed the differentials and why we needed the antiderivatives. It's to actually figure out what the original function of all of these that these differential equations were based off of was. All right, so here's another one. dy dx is equal to 2x to the negative 3. So I'll rewrite this in differential form. So dy is 2x to the negative 3 dx. And now that it's in differential form, I'll just take the integral on each side. So that gives me y is equal to, bring out the 2, so 2 integral of x to negative 3 dx. I'll use the power rule, so that will give me 2x to the negative 3 plus 1 over negative 3 plus 1 plus c. So then negative 3 plus 1 is negative 2. So it's 2x to the negative 2 over negative 2 plus c. So negative 2 over negative 2 is just negative 1. So I have y is equal to negative 1 x to the negative 2 plus c. Or I could rewrite that as negative 1 over x to the positive 2 plus c. So there you go. This is the general solution. All right, so I hope that you're enjoying this so far. So let's try another one here. So let's see. actually know what is happening. I think my pages are out of order again. So let's try 251. All right. Oh, this is better than the other one. Oh boy. Okay. So now we have dy dx is equal to the 10x squared over square root of 1 plus x to the third power. So I'll rewrite this as dy is 10x squared over the square root of 1 plus x to the third dx. All right, so that's in differential form now. And so now I can go ahead and take the antiderivative on each side. So if I do that here, I have integral. So the integral of dy is y. Well, I can't say that you spoke too soon. I don't think that these are that difficult because this is just a u substitution. I'll let the u be what's under the square root. So u is 1 plus x to the third, and du is 3x squared dx. And then I'll divide by 3 to get 1/3 du is x squared dx. All right, so now what do I have here? Well, I have integral, and I see I have a 10, and then I have the square root of the u, and then x squared dx was equal to 1/3 du. So then I'm going to multiply the 10 times the 1/3 to get 10/3, but I'll actually just bring the 10/3 in front of the integral to get 10/3 integral of 1 over the square root of u du. And then what will I do? I will go ahead and I'll rewrite the 1 over the square root of u as u to the -1/2 power. And then I can just apply the power rule. So y will be 10/3 u to the -1/2 plus 1 over -1/2 plus 1 plus c. And the -1/2 plus 1 is going to give me, that will be 1/2. So we have 10/3 times u to the 1/2 over 1/2 plus c, but then the dividing by a half is multiplying by 2 over 1, and then I can make the u to the 1/2 square root of u. So I have y is equal to 20/3, and then if I substitute the u back in, 1 plus x to the third, I have square root of 1 plus x to the third plus c. And this is the general solution. So there we go. That's the general solution to this equation here. So now, let's see. I feel like this is one where if I think I am going to go ahead and just write the answer for this one up here for you so that you can try this one on your own if you would like, but just let u be the x squared minus 8x plus 1, but then the general solution is going to be y is equal to the square root of x squared minus 8x plus 1 plus c. All right, but I kind of want you to try that one on your own because I want to just do the next page and do a couple of more difficult ones, and then we will be done for right now. So I hope that's okay with everyone, that I will have you just try that one on your own, but I don't think it's one that you can't do because it's very similar. Actually, it's almost exactly similar to the one that was part D on page 239. All right, see how we already did that one, and that was the answer that we got. So these are exactly the same as in the last section. So all I can say is that these aren't going to get any harder than this, all right? So we're just actually just giving you the problem in a different form now. So now, what are we going to do? We have dy dx is equal to x squared plus 2 over 3y squared. So what I want to do actually, remember how I said before, I want to write it in differential form, but even more importantly, I want to get all of the y's on one side of the equation, all of the x's on the other side of the equation. So in essence, you can consider it something like cross multiplying in a way to get 3y squared dy is going to be x squared plus 2 dx. So if you can get all of the y's on one side of the equation and all of the x's on the other side of the equation, this is a special type of differential equation called a separable, separable differential equation. So these are differential equations where you can get all of the x's on one side of the equation and all of the y's on the other side of the equation. So now that the x's and y's are on their own side of the equation, you can go ahead and find the antiderivative. So antiderivative, antiderivative. So the antiderivative of 3y squared with respect to y, I can bring the 3 out in front. So 3 integral of y squared dy, then use the power rule. So 3y to the 2 plus 1 over 2 plus 1. And then I can write plus c over here, but I really don't need to. I can just write one big plus c at the end, all right? So this is 3y to the third over 3 plus c, and then divide out the 3, so y to the third plus c. And then on this side, I can use the linearity property so that I can just find the antiderivatives of these two separately and add them together. So that's x to the 2 plus 1 over 2 plus 1 plus 2x plus, and I'll just make this a different c. And for my purposes, it's a c in a different color, so they're different, all right? So then this is x to the third over 3 plus 2x plus c. So then I can go ahead and then what I can do is have x to the third over 3 plus 2x plus c. I can go ahead and subtract the c's on each side. So then if you combine these c's, because they're a constant, then they're just a new constant that you can call whatever you want, all right? So you really have over here then the y to the third is equal to x to the third over 3 plus 2x plus, and let's just make the new constant h for Howard. All right, and then you really need to just go ahead and solve for y now. So you can solve for y by taking the cube root on each side. So the cube root, so y is the cube root of x to the third over 3 plus 2x plus that constant. So there you go. Are there any questions about that? I hope that that's okay, because what I'm going to do in the next one is very similar. Oh, why do you need another constant? You just because you could just think of it like this orange constant minus a yellow one. That's this new constant over here. So let's say this was like a 4 and that was a 5, then this new one would be -1. All right, so because we don't know what these numbers are, at least not today, then we have to just say, well, when I subtract the two numbers, I get this number, but I still don't know what the number is. All right, so you could call this like A on this side and B on this side, or whatever you want it to be, but really, these are different, and And again, I also think that in most cases, people just write one big C at the end, but there are cases where that could be a bad thing. All right, so just try to be conscientious of the fact that I don't really care personally if you write this C over here and just write a big C at the end when you do this, right? Or if you just don't even write that and just write a C over here. All right, so just remember that you need a different constant because these are different numbers that you don't know. But in the next problem though, what I'm going to do is I'm actually going to add the 3e to the x to the right side to get 4y prime is 3e to the x, so that the x's are on one side and the y's are on the other side. But then since y prime is dy dx, I'm going to multiply by the dy dx, the dx to get 4y dy is equal to 3e to the x dx. And now it's in differential form, and I can just find the antiderivative on each side. So over here, I have 4 integral of y dy. So that will be 4y to the 1 plus 1 over 1 plus 1 plus c, or 4y to the second over 2 plus c. But 4 over 2 is 2, so it's 2y squared plus c. Now, just like before on the last one, I'm going to pull out the constant of 3 to find the integral of 3e to the x. So that's 3 integral of e to the x dx. And the integral of e to the x is e to the x plus c. And then I am going to just go ahead and subtract the c from each side. So minus c minus c. So I have 2y squared is equal to, all right, so what will that be? 3e to the x, and then this will be plus some other constant here. So this could be s for Shaw. Don't think that I forgot about you, Shaw. And then I need to solve for y, so then divide by 2. So then divide by 2. So y squared is 3e to the x plus s over 2. And then when I take the square root, I get y is equal to plus or minus the square root of 3e to the x plus s over 2. All right, so don't forget the plus or minus when taking the square root. In the last example, I had a cube root, so I didn't actually need the plus or minus. All right, so anyway, again, this is called the general solution because I don't know what the value of s is. If I knew what the value of s was, then that is a different situation, and we'll deal with those situations next week. So that's it for this beginning introduction here of differential equations.